Hello everybody and welcome to Blockchain Expert. In this video, I'll be walking you through a project where we'll deploy an ERC-20 token and see how to interact with that token from another smart contract. Specifically, we will write an ERC-20 token contract. We'll then write a contract that allows us to exchange that token for native Ethereum. Then we will write a front end as well as some tests for this contract and kind of this decentralized app. With that said, let's get started. The first thing I want to do here is walk you through the ERC-20 kind of protocol and different functions and interfaces that are available so you understand what happens as we actually write this contract. So right now I'm on the OpenZeppelin website in the documentation section, and OpenZeppelin is kind of, I guess, a popular company or service that provides a bunch of free interfaces, contracts, and utilities related to different kind of smart contract functions or smart contract protocols. In this case, ERC-20 is what we're looking at, but they also have ERC-721 and ERC-777, which is not something we're going to talk about in this course. Anyways, as we go down here, we can see that there's kind of a few main things. So we have ERC-20. This is an interface for all ERC-20 implementations. And what that means is that any ERC-20 token contract we have should implement this interface, which defines some public functions that we should be able to call, or some external functions. Continuing, we have ERC-20. Now, this is actually a pre-written ERC-20 token contract that already implements a lot of this functionality for us, and it makes it pretty much plug and play for us to deploy our own ERC-20 token contract. We just inherit from this contract, which already exists on the blockchain, and then we are able to just have an ERC-20 token. We don't really need to do anything else, but of course, we can override the functionality if we want to do that. Then there's this ERC-20 detailed contract. We're not going to look at that, but it just implements some more, detailed information about ERC-20 tokens, like the name, symbol, decimals, etc. All right, so let's go down here and quickly have a look at this interface. So this is the ERC-20, which is the interface for ERC-20, and these are the main kind of external or public functions that we have access to on any contract that implements this, so any contract that's an ERC-20 token. We have total supply, balance of, transfer, allowance, approve, and transfer from. Now, the important thing to understand with ERC-20 token contracts is that only the person that is kind of minted tokens or has access to specific tokens has the ability to transfer those tokens, unless, however, they approve a specific address to transfer tokens on their behalf. So for example, when you go to a decentralized exchange and you want to kind of put maybe your tokens in some kind of pile or some kind of liquidity pool and allow people to buy those, really what you're doing in most situations is you're approving this decentralized exchange, the smart contracts that run that, to transfer tokens on your behalf. So we can see here that if we want to transfer, we can use this transfer function. We transfer a recipient the amount of tokens that we want to transfer. Otherwise, what we can do is we can approve a specific address to send tokens on our behalf. And typically, that address is going to be a smart contract. Now, once the smart contract has an allowance, which you can access from this function right here, it's able to use this transfer from function, which actually transfers tokens on your behalf. And it can do that up to the amount that it was approved to do. Okay, hopefully that makes a bit of sense, but that's the basic interface. Of course, balance of, straightforward, total supply, straightforward. Really, these are the four main ones you kind of need to understand. Of course, we have some events that are emitted, like transfer and approval, whenever these things occur. Okay, if you want, you can read through all of these definitions. I'm not going to do that. I'll kind of explain them to you as we get there. And I'm just going to scroll down here now to the ERC-20 token, which is the base token contract that we can inherit from. So coming here, we can see that we have a few other methods like transfer from, increase allowance, decrease allowance, underscore transfer, mint, burn, approve, burn from. Now, notice that we can use these functions from this base contract, but we can't use them from the interface. So the interface defines those core functions that you saw before, which means that a lot of the functions that are in here, like increase allowance, decrease allowance, we can only call them directly on the contract, not if this contract is being viewed through the interface of ERC-20. That's important because as we try to do some kind of decentralized exchange operations, which I'm going to show you, we won't have access to a few of the functions that are here. All right, that's kind of all I'll go through for now. Hopefully that gives you a brief introduction to ERC-20 and kind of the token protocol here. And when we go on to ERC-721, then it'll be kind of the same thing, but with the ERC-721 interface. Okay, I'm going to close this for now, and let's go to VS Code and start working on our project. So similarly to the last project, we need to initialize a new kind of NPM project. So I'm already inside of a folder in VS Code, and I'm going to type npm init. Now, after I do that, let's just go through all of the default kind of options here. I'm going to type npm install --save -dev and then hardhat. Let's wait for that to run, and then I'll be right back. All right, so now that is finished, we're going to run npx hardhat just to initialize our project here. I'm going to create a JavaScript project. This root is fine. And yes, we can add a git ignore. And then like before, we're going to install these dependencies. So I'm going to copy this line, paste this in here, and give that a second to finish. All right, so now that is finished, we have one more step. We're going to install the OpenZeppelin contract. So I'm going to have npm I or npm install at OpenZeppelin/contracts. And this is going to give us access to the interface as well as the ERC-20 base contract, which we can then import and use in our contracts. So let's do that. That's going to take a second. I'll be back when that is done. Okay, so that is finished. And now we can go into our contracts and we can delete this lock.sol. We can start writing the two contracts that we're going to have for this project. So as I was saying, we're going to have one contract, which is just going to represent our ERC-20 token. We're then going to have another contract, which will kind of be a decentralized exchange in a sense that allows us to trade in this token for a specific amount of Ethereum. You'll see how it works, and obviously you can extend the contract to be what you'd like. But for now, I'm going to make token.sol, and I'm going to make DEX.sol, standing for decentralized exchange. Okay, so let's start with our token. So what I'm going to do here is put a pragma line. I'm going to say pragma solidity, and then this is going to be the hat, if I spell solidity correctly, and then 0.8.9. Okay, now I'm going to use this version of Solidity because this is what's compatible with the ERC-20 contract that I'm going to be importing. Next, I'm going to say import, then this is going to be at open, let's put this in quotation marks, open Zeppelin, and then slash contracts slash token slash ERC-20 slash, and then ERC-20.sol. Now, that should actually not give you any errors. It's saying source not found. Okay, interesting. That should be installed, assuming that I spelt this correctly, and I didn't. I have to spell Zeppelin correctly. But we should have that in our node modules folder because we installed this module. I also realized that I need to put contracts here, and hopefully now it's going to fix it. Okay, great. So now that is good. It's finding that in node modules. Okay, so that's the contract we're going to be using. Now we're going to make a contract. I'm going to just call this token, and I'm going to say that this is an ERC-20 token or contract. Now that's what we imported here from this file. Okay, now that we've done that, we're going to write a constructor, and inside of the constructor, we're going to take our initial supply of tokens. Now, there's all kinds of ways that you can initialize an ERC-20 token contract. There's a lot of private methods you can call, which I'm going to show you in a second. But for simplicity here, what we're going to do is we're just going to mint the initial supply of tokens to whoever deployed this contract. So they're going to get the entire supply of tokens, and then they can distribute those tokens how they see fit. So I'm going to go here and say ERC-20. This is calling the constructor of the ERC-20 base contract. And what I need to pass here is the name of my coin. In this case, I'm going to call it Tim coin. Obviously, you can call this whatever you want. And then the symbol for my coin, which is going to be a 3-symbol string. In this case, it's going to be Tim. Expected end quote for a string. I'm not sure why I'm getting that error. Let me have a look here. Looks good to me. Hopefully, that's going to go away in a second. Okay, it did. And now inside of the constructor, I'm going to call the underscore mint function, okay? And I'm going to pass to the message.sender the initial supply of token. All right, so that's all I'm going to do for this contract. Now, obviously, this is very limiting, and this doesn't allow you to kind of have a more advanced use case of an ERC-20 token. what you could do is make it so that multiple addresses can mint. Maybe you can only mint a certain amount of tokens per day. You could write this however you want, using this mint function, and then of course adding your own functions as well to the token contract. However, I want to show you using tokens, so I don't want to focus too much on creating the token. I want to show you how we interact with it from a smart contract. Now let's go back here quickly to our OpenZeppelin docs, and let's have a look at our ERC-20 base contract. Okay, so here we have mint. If we go to mint here, it says creates amount tokens and assigns them to account, increasing the total supply, emits a transfer event with from set to the 0 address. Now notice this is an internal function. Since it's internal, I can't call it from outside of the smart contract, so I need to kind of explicitly call this from the constructor, which is what I'm doing. Now, all of these underscore functions are like private or internal functions, okay? So same with transfer here, burn, approve, burn from, etc. You get the idea, so you can use those kind of functions only internally from the contract. Okay. Now that we have our token contract, which I realize I put in the wrong file, so I'm going to copy this and just paste it into token.sol. Now what we can do is write our DEX contract. Now what I'm going to show you in this contract is how we interact and kind of transfer this token from within this contract. So let's write our pragma line. I'm going to say pragma solidity and then 0.8.9. Okay. And then, sorry, the hat symbol needs to be above here. Now I'm going to say import, and then this is going to be at open Zeppelin / contracts / if we can spell this correctly, /token / ERC-20 / and then I think actually all we need here is the ERC-20.sol, which is an interface. Okay, so that's correct. Now I'm going to say contract DEX like that. And now we can start writing our contract. So the way I want this contract to work is that whoever deploys this contract is going to be the person who wants to sell some of their tokens. Now I'm going to make this flexible so that they can sell any kind of token that they want. And the way they're going to specify what token they're selling is by kind of sending the address of that token contract to this contract. So we need to store what token it is that we're selling, and then we're going to store the amount, or not the amount, sorry, the price that this user wants to sell this token for. So we're just going to make it so the owner of this token can sell it. We're not going to make it so other people can, but of course you could adjust this contract later on so that anyone could use this to sell any kind of token. That's just a little bit beyond the scope of what I want to show in this project. So I'm going to say ERC-20, and then I'm going to make this public so anyone can see this. And I'm going to say associated token. So we're going to store this, and I'm also going to take a uint price and an address of the owner of the contract, or the deployer of the contract. Now I'm going to write a constructor, and in my constructor, I'm going to take an ERC-20, and then this is going to be underscore token, and I'm going to take a uint underscore price. So again, what's going to happen here is the owner of whatever token it is going to deploy this DEX contract. They're going to specify what the address of this token contract is. And the reason I'm using ERC-20 here is I want to ensure that they only pass the address of a token that adheres to this interface. So once they pass that, it's going to kind of, let's say, load the actual contract inside of this contract and allow me to call any method on associated token that's on this ERC-20 interface. Hopefully that makes a bit of sense, but when you pass an address through as ERC-20, that allows us now to use this kind of contract as an ERC-20 contract. Okay, we also take the price that they want to sell each of their tokens for. Realistically, we could make a way for them to change this, or they could specify that when they're actually like kind of telling us how many coins they want to sell. For now, though, we'll just put it in the constructor. Okay, so I'm going to say my associated token is equal to my underscore token. I'm going to say the owner is equal to the message.sender. I'm going to say the price is equal to underscore price. Now that I have that, we need to talk about how the owner of this contract is going to allow this contract to actually sell coins for them. So what I want to do is make a function called sell. Now, this is going to be an external function that only the owner of this contract should be able to call. So in fact, before we go any further, let me write a modifier here called only owner. We've seen this a few times, and I'm just going to require that the message.sender is equal to the owner of the contract, and I'll say you are not the owner. Okay, and then we'll call our underlying function. So let's now modify this function with only owner. Okay, and now we're inside of sell. So what's going to happen for sell is we are going to check and see if the owner of this contract has given an allowance to this contract from the token contract. Seems a bit weird, but what needs to happen before we can sell any tokens for this user is they need to call the allowance or kind of approve function on the ERC-20 token and approve that this contract here can kind of transfer tokens on their behalf. That way we can say, okay, this many tokens are for sale because we know that we're able to transfer that many. And then we can, well, transfer those tokens when somebody actually buys them. So what we're going to do inside of this sell function is we're going to check and see if the owner of this contract, the DEX contract, has approved this contract to transfer tokens on its behalf. Now, if it has, what we're going to do is take whatever that allowance amount of tokens is and transfer them to this token contract so that the owner of the token no longer owns those tokens, the contract owns it, and then we will allow users to buy these tokens from the contract and then give the proceeds to the owner of the tokens. So on this token contract, what's going to have to happen is we're going to have to call approve, passing in this DEX contract address. We're going to approve this contract to sell or to have access to, say, 100 tokens or 200 tokens or whatever the amount is. We're then going to take in this sell function all of those tokens we have approval for, transfer them to this contract, and then keep them in this contract until someone decides to buy them. So let's write this out. I'm going to say uint allowance is equal to our associated token dot allowance. Notice how it popped up that method because I'm using the ERC-20 interface. And what we need to do here for allowance is pass message.sender and then address this. Now that's the way this function works. It tells us the allowance of message.sender's tokens for this contract, right? So we're checking how many tokens we have access to. So to call this method, we're going to require that the allowance is greater than 0. And we're going to say, you must allow this contract access to at least 1 token. Okay, great. Now, what we're going to do is we're going to send those tokens to ourselves. So we're going to say bool send is equal to associated token dot transfer from, and we're going to transfer from the message dot sender, if we can put this here, to the address this, and the amount that we're going to transfer is whatever the allowance amount is. Because remember, this method here is going to return to us how many tokens this address, so our contract, has access to. All right, now we are going to require send, and otherwise we'll say failed to send, like that. Okay, that is all we need for this sell function. So again, the idea is we approve this contract, we then call this sell function, and then this contract will transfer the tokens to the contract, and then we will be able to actually sell them. All right. Now, what I want to do is also make it so the owner of these tokens at any point in time can withdraw them. So I'm going to say function withdraw tokens. And then this is going to be external only owner. Only the owner can call this. And we're going to say uint balance is equal to associated token dot balance of. And then this is going to be address this. So what we're doing is seeing how many tokens we have, like this contract has access to. That's how many that we would have transferred to ourselves previously that haven't yet been sold. And then we'll say associated token dot transfer, and we're going to transfer to the message.sender the entire balance. So this will allow the owner of these tokens to withdraw any tokens that are in this contract that they want. It's just going to give them all of it. We could, of course, put an amount that they could request, but I'm just going to make it so it just gives them the entire balance. All right, perfect. Now, we also want to make a way for the owner of this contract to withdraw any funds that this contract has collected. Now, at this point, we haven't collected any funds, but I am about to write a buy contract or a buy function that's going to allow us to actually buy coins at the specified price from this contract. Okay, so let's say function withdraw funds, and this will be an external, again, that only the owner of the contract can call. And what this will do is just send the entire balance of the smart contract to the owner. So I'm going to say bool sent is equal to, then this is going to be payable, message.sender dot call. And for the value, we are going to specify address this dot balance like that. And then we'll pass our empty string. And then, of course, we will require that sent was true. Okay, let's put our semicolon. All right, so that is it for withdraw funds. Now that we have that, let's write a function that allows us to get the price of a token. So let's say function get price, and we're going to say uint, and then this is going to be the number of tokens. And then this is going to be actually just a public function. We'll say public view returns a uint, and we're going to return the price in way to buy this many tokens from this contract. So the way we do that is we simply return the number of tokens multiplied by the price. All right, now we are on to the buy function. So I'm going to say function buy. I'm going to say uint num tokens. This is the number of tokens that this user would like to buy. And we're going to make this an external payable function. Now, what we're going to specify, first of all, or what we're going to do for our kind of precondition checks is ensure that we have enough tokens for this user to be able to buy them, right? So we're going to make sure the number of tokens we have, our balance of tokens in this contract, is greater than or equal to the number of tokens that they are requiring. We could write a modifier for this, but I'm just going to do it as a basic require statement. So I'm going to require that the number of tokens is less than or equal to the associated token dot balance of, and then this is going to be address this. Okay, and we'll say not, or yeah, we'll say not enough tokens. Okay, so that is our first kind of precondition check. Next, what we need to do is figure out what the price of these tokens are going to be and make sure that the user submitted exactly the correct amount of Ethereum to purchase these tokens. So I'm going to say uint price is equal to, and then this will be get price of the number of tokens. Okay, now that we have that, we are going to require that the message.value is equal to the price, and we're going to say invalid value sent otherwise. And now, if they did actually send a correct or valid amount, we will transfer them the tokens. So we're going to say associated token dot transfer, and we're going to transfer from ourselves to this user. So we're going to pass in here message.sender, and the number of tokens will be, well, the number of tokens. Perfect. Now, what is the issue with price here? This declaration shadows an existing declaration. Okay, so let's go price for tokens just to get rid of that warning and make this price for tokens. Okay, I think that is good. Nice. Now that we have that, the last function that I'm going to write is just a function that gives us the remaining balance of tokens that we have in this contract. So I'm going to say function get token balance, and this is going to be a public view that returns a uint, and we are going to return the associated token dot balance of, and this is going to be address this. And now that I think of it, since we've written this function, what I want to do is actually use this function inside of this buy, function. So I'm going to put here get token balance. So now we're using this public function that we wrote. All right, so at this point, we are actually finished with our contracts. Now what I want to move on to is writing our tests. We're going to write a test for the token contract as well as for the DEX contract. Once we have those, we will then move on to writing the deploy script. Then we will get into the front end where we actually interact with these contracts, which is kind of the more interesting aspect of this project. So let's go into test here, and let's actually clear this test file. I'm just going to copy this line because that's the one that I want. So let's clear this here, and let's write two files. The first file is going to be token.js, and the next file is going to be dex.js. Okay, so let's do token first. I'm just going to copy this in. I'll just copy it in Dex while I'm at it. Okay, so for this test, I'm going to write it a bit more simple than we've written the previous test and just show you different ways we can go about doing this. So I'm going to say describe, and I'm going to put inside of here token. And then this is where we'll write our test. Now, I'm going to specify a few global variables here. So first of all, I'm going to say let token supply equal 100. Now I'm using a string here because a lot of times our contract is actually going to require what's known as a big int, which is kind of a special type. And that type can be kind of implicitly converted to from a string. Seems a bit weird, but if you ever get any errors related to kind of numbers, try passing those numbers in as a string. I'll talk more about that when we get to that point. Okay, next I'm going to say let token, and then I'm going to say let owner, let ADDR1, and let ADDR2. Now these are the global variables we're going to need for our tests. First thing I need to do here is deploy my contract. Now what I want to do is deploy my contract before each set of tests that I have. So I'm going to use something called before each, which is a part of, I believe, the Chai library or the Mocha library or whatever it is that we're using here for testing. Okay, Mocha, that's what it's a part of. So before each, and I'm going to go async, and then I'm going to write my function. Okay, inside of here, I'm going to say my owner, ADDR1, and ADDR2 is equal to await ethers, if we can type this properly, dot get signers. Okay, we have that. Next, we're going to say const token is equal to await ethers dot get contract factory. Okay, and for the contract factory, we want the token contract. Next, we're going to say token is equal to await, and then it's going to be token like this dot deploy. And what we need to pass when we deploy here is our constructor argument, which is our token supply. Okay, so there we go. We now have written the deploy script, or what's going to deploy it before our tests. Now, the way that before each works is that it's going to run this code before every individual test case that I have, specifically all of the test cases within each of the describe blocks, which I'm going to write now. So I'm going to have a describe block here. This first one is going to be for deployment, and this will take a function. And the next one here will be for transactions. And again, this will take a function. So before all of the tests within deployment and transaction is going to run this before each. Okay, so for deployment, the first thing we want to do is make sure that this contract is going to assign the total supply of tokens to the owner who deployed it. So we're going to say it should assign total supply of tokens to the owner slash deployer. Okay, this is going to be an async function again. And inside of here, we're going to say const owner balance is equal to await token dot balance of. And then for the balance of, this is going to be the owner dot address, which we have access to in the global scope. And then we are going to say expect, and then we're going to say await token dot total supply, which is another global function or external function we have access to, dot to dot equal the owner balance. Okay. So since this before each is going to run before this describe block, we know inside of this first test case that we should have already ran the constructor, hence the owner, the deployer of the contract, which by default is the first account here, should have access to the entire balance. So that's what we're going to verify here, that whatever the total supply of the contract is equal to the balance of our owner. Before we go any further, actually, let's run this. So I'm going to type npx hardhat test and check this out. Okay, perfect. So it works. It says should assign total supply of tokens to owner deployer. Correct. Nice. Next, what we want to do is just test doing a simple transaction so we can see if tokens are transferred from one account to another. We know that this is going to work, but I just want to show you how we test this in case you were to say modify the contract pretty heavily. So I'm going to say here, should transfer, and then we're going to say tokens between accounts. Okay, and I'm going to do another async function here. And what I will do is transfer from the owner address to, let's say, address 1. So I'm going to say await, and this is going to be token.connect, and we will connect the owner address. Now, one thing to note here is that by default, we're going to use this first owner address. So I don't really need to write this. If I want to be verbose, I can, but I'll actually remove it. And that's why you saw here when I did token.balance of, well, actually that will work no matter what, but just wanted to say we don't need to write connect when we're using this first address because that is by default the one we're going to use. Anyways, continuing here, we're going to say wait token.transfer, and we're going to transfer to addr1.address. Let's go with 50 tokens. Okay, we're going to say const addr1 balance is equal to await token.balance of, and then addr1.address. Then I'm going to say expect addr1 balance .to .equal 50. Okay, perfect. Now I'm going to copy this. I'm going to do one more test. Now in this test, we are going to check and make sure that it does not allow us to transfer tokens if we do not have a sufficient balance. Okay, so let's do this. We're going to say await expect, and then this is going to be token dot connect addr1 dot transfer, and then we're going to transfer to addr2 dot address, and the amount of tokens that we want to transfer, let's go with like 51, so more tokens than we currently have access to, and let's expect this dot to be reverted. All right, that's really all we need to check here, is that when we try to transfer more tokens than we have access to in this account, it fails. Okay, that's all we're going to do for these test cases. Let's run this and see if it works. And we should see here that we pass all of our tests. This is working successfully. We really didn't need to write many of these test cases. I just wanted to show you kind of how we would test token transfers, right? Okay, now that we've written it for token, we're going to write our test cases for our decentralized exchange. So I'm going to say describe, and this will be DEX. And then, of course, let's have our function. Now, for DEX, we're going to do a similar thing to what we did before. And what we actually need to do in DEX is we need to deploy our token contract, because for our decentralized exchange to work, we have to have access to a token contract. So let's actually go to token or token.test, and let's copy this first aspect here up to this before each, or including this before each. Okay, so I'm going to paste that in, and actually what we want to do here is exactly this. We want to deploy our token contract with the total supply equal to 100. We can change that amount if we want, and then we want to deploy our DEX contract afterwards, and we want to pass the address of this token contract. So I'm going to say const DEX is equal to await ethers.get contract factory. We're going to grab DEX, then we're going to say that our DEX, which we need to write here, so let's say let DEX, we're going to say DEX is equal to DEX.deploy. We're going to await this, and as the arguments to deploy here, we are going to pass the token.address, and then what we want the price in way of our token to be. So I'm actually going to do another variable here. Let's kind of spread these out a bit, and let's say let price equal 100. Okay, and then for the price, I will put price here. All right, so these are the two constructor arguments that we need for the DEX contract. Now that we have that, we want to test components of this. So the first thing I want to test is selling. Then I want to test some of the getter functions we have, and then buying, and of course, withdrawing the tokens and withdrawing the funds. So let's write our describes that we're going to need. So I'm going to say describe sell. let me copy this and I'll write the other ones that we need. So we have sell. We have, I'm going to call this getters, so different getter functions. We're going to have buying. So let's test buy. And then I'm going to have withdrawing. So let's go withdraw, and then this will be tokens. And then let's go with withdraw funds. Okay, perfect. So I think that's all we need for right now. Let's get started inside of sell. So the first test case that we'll write is that it should fail when we call the sell function if we have not approved this contract to sell any tokens or to transfer any tokens on our behalf. So I'm going to say it should fail if contract is not approved. Okay, now this will be async as usual. And inside of here, I'm just simply going to await, expect dex.sell, and then .2.be reverted. Now, the reason we expect this to be reverted is because we did not approve the DEX contract. And as we had inside of here in our sell function, if the allowance is not greater than 0, which it won't be here, then it's going to fail. It's going to revert, right? So that's what we have. Okay. The next one is that it should allow us to actually transfer tokens to this contract if we have approved it, right? So I'm going to say it should allow DEX to transfer and then tokens like that. Then I'm going to say async. And what we need to do here is actually approve the transfer of tokens. So to do this, I'm going to say await token dot approve, and I'm going to approve of the dex dot address, and I'm going to approve 100 tokens to be transferred. Now that's actually all I'm doing for this test case. I'm not going to check if the sell function works yet. I'm just going to make sure that I can actually approve this address. Then I'm going to move on to my next test case. And notice that this test case, will affect the next one because this before each only runs before each describe, not each individual test case. Okay, so now I write it, and I'm going to say should not allow a non-owner to call the sell function. So we'll actually do this one first, and then we'll do the kind of successful sell function. All right, so I'm going to say await expect dex.connect. I need to do this because I don't want to use the owner now. I'm going to connect to ADDR1. I'm going to say .sell, .2, .b reverted. Okay, and then lastly, we're going to say should sell, and I'm going to say here, sell should transfer tokens from owner to contract. Okay, and here we're going to say await expect dex.sell, and then this is going to be .2.change token balances like that. The first thing that we need to pass is actually the kind of token contract that we're calling this on. So we're going to say token, and then we're going to pass our different addresses. So I'm going to say owner.address, dex.address, and then I'm going to say -100 and 100. Okay, let me just explain this quickly. So we have now, at this point, approved this contract to take 100 of our tokens and sell them. So here, when I now call dex.sell, I'm expecting the token balances to be changed for both the owner, which is the one calling this contract, calling this function, and the actual contract itself. I'm expecting the owner to lose 100 tokens and the dex contract to gain 100 tokens. And I need to specify what token I'm talking about, so I pass that first. Perfect. So that should be it for doing our transfers or doing our sell. So now let's go npx hardhat test, and let's see if this tests it. All right, so we actually got an error here. It said sell should transfer tokens from owner to contract. VM exception while processing transaction reverted with recent string. You must allow this contract access to at least one token. Okay. Interesting why that happened. Let me have a look here and see what the issue is. All right, so my apologies for the cut here, but I need to make a quick correction. Previously, I was telling you that before each runs before each describe block. That's actually not true. it runs before each individual test, hence why our test case was failing. What I actually want to change this to is before, and what before does is run before everything that comes after it. So not before each describe block, just before all of these describe blocks at once. Now, the reason I'm going to do that for this test is I actually want to maintain the state for every single test that I have, regardless of what describe block it's in. My apologies, I should have clarified that when we started writing this code, but I just mixed up before and before each. Going back to token, I've also changed this now to say before rather than before each, so that this runs before all of this, not before each individual test, even though the test was failing or passing, regardless. Okay, so let's go back to dex.js. Let me close these files. Okay, so now we're going to run this code and just make sure it's actually working again and passing all of our tests. And it is. Okay, nice. So now, at this point, we've transferred 100 tokens to the DEX contract. So I want to test my getters, and I want to make sure that the get price and the get token balance function are returning the correct values. So I'm going to say should return correct token balance. This again will be async. And what we're going to do here is say expect await dex.get token balance dot, if we put this on the right line, equal, and then 100. Okay, so that's what we need for this. Now I'll actually copy this, and for our next test, we're going to say should return correct token price. And we'll change this to say get, and I think we'll go get price. And we're going to see the price of 10 tokens, which should be equal to the price multiplied by 10, right? Okay, so that's it for our getters. Let's quickly test these out and make sure those are working. Okay, looks like they are. Now we will continue to buying. So we want to allow users to buy tokens, and then those tokens need to be transferred from the contract to the user. So for our first test, we're going to say user can buy tokens. We're going to go async like this. And here we are going to expect that, actually, we're going to await the expect. I'm going to say await expect dex.connect addr1.buy, and we're going to buy 10 tokens. And since this is a payable function, we need to pass to this 1,000 way. And let's actually go quickly to Dex and make sure we marked this as payable. So if we go to buy, yes, it is external payable. Okay, I just want to make sure I did that correctly. So 1,000 is the correct price for buying 10 tokens. That's why we're going to pass that. And we're going to expect that this changes token balances. So .to.change token balances for the token. For the accounts, this is going to be the dex.address and the addr1.address. And we are going to expect that the balances are -10 and 10 respectively. So our account gets 10 and our DEX contract loses 10 if this is successful, right? Okay, so that's test 1. Next, we're going to say user cannot buy invalid number of tokens. Okay, and then this is going to be async. And inside of here, we're going to say wait, expect dex.connect. This is going to be addr1 again, dot buy. And we're going to try to buy 91 tokens, which we don't have access to. And then we'll pass here value. And we can actually pass the correct value, which will be 91,000. Is it 91,000 or 9,100? I think it's going to be 91,000. I think that's correct. No, should be 9,100 now that I think of it. Yeah, that's going to be correct. And then we're going to say .to.b.reverted. Okay, so that should be good. And now let's just do another test here. And we're going to say user cannot buy with invalid value. So now we'll let them buy, say, 5 tokens, which is a valid amount, but we'll pass an incorrect value, say, of like 510. And we're going to expect that to be reverted. Okay, let's test this now and see if this is working. And we should see that all of the tests pass. Perfect. Okay, now we want to test withdrawing our tokens and withdrawing our funds. We should have 90 tokens remaining in the contract. and our user should be able to withdraw these. However, if you are not the owner of the contract, you should not be able to do that. So let's start by checking that. Non-owner cannot withdraw tokens. Okay, and let's go async. And let's go await, expect, dex.connect, addr1 dot withdraw, and this will be tokens .2.b .reverted. Okay, and then we can copy this and we can say await owner can withdraw tokens, and this time we don't need to connect. We'll just make it the owner. We'll say withdraw tokens. We will expect this to change token balances for the token. And then we'll say dex.address and owner.address. And then this will be -90 and 90 respectively. Okay, let's try this out. Run our test. And we can see that all is fine. Okay, lastly, we need to be able to withdraw funds. So let's say owner can withdraw token proceeds. So essentially however much people bought the tokens for. Okay, we're going to say await. And then this is going to be expect dex.withdraw, not tokens, but withdraw funds. Okay, and then again, .2, and this time it's going to be change ether balances. And for the balances, we're going to say owner.address, dex.address. We could do it in any order we want, doesn't really matter. The owner should be getting 1,000 Wei, and the dex should lose 1,000 Wei because that's how much we bought for here. Okay, lastly, we're going to say non-owner cannot withdraw token proceeds, and we'll say async await expect dex.connect addr1 dot withdraw funds .2.b reverted. Okay, a lot of testing. Let's write this, or let's run this, sorry, and see if it works. And we should see that all is good. We pass all of our tests. Perfect. Our testing is done. Writing the contracts is finished. Now we need to deploy and we need to write our front end. All right, so we are now moving on to our deploy script. So let's go to deploy.js and let's essentially clear everything inside of here. Now what I'm going to do is bring in the function that we had in the previous project that allows us to write our deployment info. So this function is going to, as it shows here, just write the information about our deployed contracts to a JSON file so that we can, what do you call it here, kind of get information about what the address of the contract is, the API, all of that kind of stuff. Now to use this, we need to import fs. So I'm going to say const fs, which stands for file system, by the way, is equal to require, and then this could be fs/promises. Okay, now let's start deploying our contracts. So first, I'm going to say const token is equal to HRE.ethers, and then this is going to be .get contract factory, and this is going to be token. Then I'm going to say const token is equal to await token.deploy, and let's put that here. I'm not sure why it's kind of doing this weird, what do you call it, like double deploy or double await thing here, but let's fix that. And we're going to deploy this contract with a total supply of 100. Okay, now that we have that, we're going to say const dex is equal to HRE.ethers.get contract factory, and then this will be at dex, and then same thing, we're going to say const dex is equal to HRE, not HRE, sorry, await, and then it's going to be dex.deploy, and we're going to deploy this, and we're going to pass the token.address, and then we'll pass 100 as the price for each of our tokens. Okay, now that we've done that, we're going to await token.deployed, and we are also going to await dex.deployed, and then we're going to write the deployment info for both of these to a JSON file. So I'm going to say await write deployment info, and then this is going to be for our token, and for the file name, I'll make this token.json, So I just realized I need to change this to be all capitals DEX, okay? And then I'm going to await, write deployment info, and then this can be DEX and then DEX.json. Okay, perfect. That's actually all we need for our deployment script. This will now deploy first the token contract, and then it will deploy the DEX contract with token.address as the coin that we are going to be, or the token, sorry, that we are going to be selling. Now that we have our deployment done, we can start working on our front end. Now, I've written a more advanced front end this time, or we are going to write a more advanced front end this time that allows us to interact with pretty much all of the components and functions of our smart contract. So let's make a function like before, call this front end. And inside of here, let's make two files. Again, we'll go with base.html and we'll go with script.js. Let's start inside of base.html. I'm going to use my templating tool here from VS Code, and I will change the name to be DEX ERC-20. We can go all capitals for our ERC. Okay, now what do I actually need to do here? Well, I need to get information about, for example, the token price, the number of tokens available, how many tokens I have in my balance. I then need a way to grant the DEX contract access to my tokens. I need a way to actually call the sell function to sell those tokens to the DEX contract, and I need a way to buy different tokens. Actually, quite a bit of stuff that we need to do. Firstly, though, I'm just going to bring in my script tags. Feel free to pause and copy these in, but this is the script tag we need for Ethers, and this is what we need for linking our script.js file. And now I'm going to start writing a bit of HTML to kind of generate the body of our page. I'm not going to make it look too great, but I'll make it so that we have all the functionality we need. So I'm going to say div. I'm actually going to put a class here called container, and we will write this class in a minute and kind of the CSS styles. I'm going to end my div here, which is done for me automatically. Okay, now I'm going to have another div, and this div inside of here is going to be class equal row. Okay, and inside of here, we're going to have a few more divs. We're going to say class is equal to item. For some reason, I keep missing my quotations. And we're actually going to have 3 items in this row. So you can kind of see based on how I'm doing the classes, how I'm laying this out. We have a main container. We have a row inside this container. We have a few items inside of our row. Okay, for the header here, I'm going to say h2. I'm just going to call this general information, kind of going above the row. And then I am going to, in my first item here, make a smaller header and call this token price. And then I'm going to put a span. I'm going to say ID is equal to token price, like that. Okay, so this is where I'm actually going to write what the token price is once we call the function that gets the token price for us. So I'm going to say button. I'm going to say onClick is equal to get price. And then I will say here, update price. Okay, so that is what we need for our first div. I'm going to copy this and put this inside of my second div. And next, this is going to be tokens available, if we could spell that correctly. Now for the ID, I'll make this, let's go with, yeah, we can go tokens available. That's fine. And then we can say update token balance, like that. Or actually, let's make it update tokens available, because token balance could be your own token balance. Okay. Lastly, for our next item here, let's copy this. And this is going to be the balance that you have. So I'm going to say my token balance. Let's fix our H3 here. And this will say token balance. And then I'm going to say update. Let's go my tokens. And we need to change these functions. So we're going to say get available tokens. And this is going to say get. Let's call it my tokens. Actually, let's go get token balance. Okay, so that is going to be row number 1. Or let's call it not row number 1. Well, it is row number 1, but really section number 1. Now what I'm going to do is put another container here. Say div class equals container. I'm going to kind of replicate the same format I went with before. So I'm going to put div here. This is going to be a row. So I'm going to say class is equal to row. We'll write these classes in a second. And inside of my row, again, I'm going to have a few items. So let's go div class is equal to item. And for this first item, this is what's going to actually grant our DEX contract access to our funds or to our tokens. So I'm going to say H3. I'm going to say grant DEX access like this. And I'm going to put a div here. And I'm actually going to put an input field. This input field type, will be number. So type equals number. I'm going to say the minimum is equal to 0. I'm going to say the placeholder is equal to, and then it's going to be enter token number, or enter, really, we should probably say number of tokens. And for the ID, this will be equal to token grant. Okay, now beside that, I'm going to make a button. And this button is going to say grant. And we're going to say on click is equal to grant access. Okay. Lastly, or not lastly, but within this row, we're going to need another item. So we're going to say div class is equal to item. And this is going to allow us to sell tokens. So I'm going to say H3 sell tokens. They will make a button. We'll say sell. And on click, you guessed it, this will call the sell function. Okay. Now, just to clarify why I put a div inside of this div, it's so that this div maintains everything horizontally. So rather than having my, my input and my button be on new lines, I'm going to have them kind of beside each other. You'll see why that's the case when I start writing the item, row, and container CSS. All right, so that's almost it. The last thing we need to do here is make one more container. So class is equal to container. And we are going to say for this container, this is the user controls. And this is going to allow us to buy tokens. So I'm going to make a div class is equal to our item. Inside of this div, we'll have an H3. We'll say buy tokens. We can actually copy this div right here. And we're just going to change this to, rather than token grant, we'll say buy tokens. And rather than grant access, we're going to say buy tokens. And we'll change this button to say buy. Okay, perfect. Actually, I'm going to change this from buy tokens to say tokens to buy. Okay, now let's write our CSS, and then I can show you what this actually looks like. So I'm going to put a style tag up here, and the CSS that we need is our container, our row, and our item. So I'm going to say container. We want to use flexbox, so I'm going to say display flex. I'm going to say the flex direction is column. I'm going to say align items center. And I'm going to say gap is equal to 10 pixels, which is going to be the gap between all of our items. And I'm going to put a margin top for each of our containers of 20 pixels. Okay, now after container, we want a row. So we're going to say dot row display, and this is going to be flex. We're going to say the flex direction is row, and we're going to say the width is 100%. And not inside of a string, just 100% like that. Then we're going to say dot item. Again, we want to use flexbox. We're going to say display flex. We're going to say the flex direction is column. We're going to say flex equals 1. So each of our items take up an equal amount of space inside of our flex container. We're then going to say align items center. Why are we getting an issue here? I need to put a semicolon, and then we're going to say justify content center as well. Okay, that's all we need for our CSS. Now, let's see how this looks. So let's go live and have a look here on our web page. Okay, so this is what I've set up. Obviously, not the prettiest or most modern web page we've probably ever seen before, but I think this is good enough, and it kind of separates things out so we can at least see it. Now, obviously, none of this stuff is going to be working right now, so we need to actually hook that up, which we can do now. All right, so let's go into script.js and let's start writing what we need to connect to MetaMask and perform all of these operations, essentially all the functions that we've kind of, let's call stubbed from our base HTML. So I'm going to say const provider is equal to new ethers dot provider dot web3 provider window dot Ethereum. Okay, we're going to say let signer like this. We'll actually assign the signer in a second. Next, we're going to say our const token ABI. We'll fill this in a minute. Then we're going to say const token address. Again, we'll fill that in a second. And then we'll say let the token contract equal null. And again, we'll fill that in a second. Okay, now we want to do the same thing for our DEX. So I'm going to say const DEX ABI is equal to that. Const DEX address is equal to an empty string. And we're going to say let the DEX contract equal null. Okay, so we need access to both the token and the DEX contract. We need the token so we can approve the transfer. And then we need DEX to actually perform all the other operations. So I'm going to write a function now, async function get access, similar to what we had in the previous project. And I'm going to say if token contract, then return, because we've already done what we need to do in this contract. Otherwise, I'm going to say await. And this is going to be, provider dot send eth underscore request accounts empty array. And then I'm going to say signer is equal to provider dot get signer. And I'm going to create the token contract in the DEX contract with this signer. So I'm going to say token contract equals new ethers dot contract. And to initialize this, we need the token address. Okay, not the ABI, the token address, then the ABI, then the signer. And of course, we want the same for the DEX. So DEX contract is equal to new ethers dot contract, DEX address, DEX ABI, and our signer. Okay, so that is our get access function. Now, before we go any further, let's actually deploy our contracts using the deploy script. Let's get access to our ABI and our address, and then we can continue. Okay, so as always, what we need to do here is split the terminal. First, we're going to write run npx hardhat node, and then we'll run our deploy script. So this is going to be npx hardhat run -- network localhost, and then /scripts /deploy.js. All right, let's run this and see if we get any errors or if this works okay. And we got an error. It says token.deploy is not a function. Okay, so let's go to our deploy script and see what the issue is here with token. All right, so the issue is that I forgot to await my contract factory. Hence, this was a promise that I was trying to call deploy on, and that didn't work. So let's add our 2 awaits here. And now let's rerun. And we should be all good. And are we good? Yes, we are good. Okay, so we can see that both these contracts have been deployed. And now we should have 2 files. We should have token.js and dex.js, sorry, not js.json. And what we want to grab is the ABI as well as the address from both of them. So this is dex. Let's grab the ABI and put it in here. Okay, let's grab the address and put it here. Okay, then we want to get access to our token.json. We can grab the address and put it here, and grab the ABI and put it here. Okay, so now we have that information. Let me clear the screen, and now we can continue here with the rest of our JavaScript. Okay, so the first function we can write here is get price. So I'm going to say await function get price. And for all these functions, we're going to await getting the access just to make sure we have access to MetaMask first. And sorry, this is not await, this is async. Okay, now for the price, we're going to say const price is equal to await the DEX contract dot get price. We're going to get the price of 1 singular token. We're then going to say document dot element get element by ID And we have this span called token price, which I will show you in a second. We're going to say dot the inner HTML is equal to the price. And then we can return the price in case we want to use that later on. Okay, so that's the get price function. If we go to base.html, we should see that token price, we are calling get price, and we have token price here, which is where we're going to put whatever that price is. Okay, let's go back to script. That's all we need for that. Next, we're going to write our get token balance. Okay, so this needs to be a function. We're going to say await get access like usual. Inside of here, we're going to say const balance is equal to await token contract. And then this is going to be balance of, and then this will be await signer dot get address, which is the current signer account or MetaMask account that we are connected to. Then we're going to say document dot get element by ID. And I believe I called this the token balance dot inner HTML is equal to this balance. Okay, next we want to get the available tokens. So I'm going to say async function get available tokens. And then inside of here, again, we're going to wait get access. You can see this is pretty redundant. We're going to say const tokens is equal to await the DEX contract dot get token balance. We also could use the token contract, but I'll just use this one instead. I'm going to say document dot get element by ID, and this will be our available tokens dot inner HTML is equal to our tokens. Okay, let's try out these three functions before we go any further. So I have my live server running. I'm going to refresh. I'm going to view my console and see if I get any errors here. And let's see what it's saying. It's saying uncaught reference type require is not defined. I don't know why this keeps getting added. I'm just going to remove that require statement. I'm going to go back here and let's see if this works. Okay, so no errors. Let's try to get the token price. That's 100. Tokens available. We got an issue. It says inner HTML is not available. That means I probably spelt this wrong. So let's do that in a second. And same thing here, inner HTML on null. Okay, so let's go back to our HTML. So we have tokens balance and tokens available. Those are our two IDs. I probably just used the wrong ones. So let's swap these out. Token, is it tokens balance? Yes, that's what it is. And available tokens. Let me just copy what it is here to make sure I didn't spell anything incorrectly. Okay, let's paste that in. And I had it the other way around. That makes sense. Okay, let's go back to our HTML. Let's refresh. Let's run this. 0, 0, and the price is 100. Perfect. That's what I was looking for. All right, now we want to write the function that grants this contract access to our tokens. So I'm going to say async function grant access. And I'm going to say await, and this is going to be get access. I know these are a bit confusing, but we're granting access to the contract here. So first of all, I'm going to get the value that I want to give to the contract. So it's going to be document.get element by ID. And then this will be token grant. I believe that's what I called it. Dot value. That's getting the value from the input field. Then I'm going to await token contract dot approve. And I'm going to pass the DEX address and the value. I'm going to say dot then. And we're just going to do an alert that says success. And I'll put a dot catch here, and I will have error. And then I will alert this error. Okay, so that should now work to grant access. While we're at it, we might as well write the rest of the functions. So let's say async function cell. Okay, inside of cell, we're going to say await get access. We're going to say await DEX contract. So let's write that out here. Dot cell. We're going to say dot then. Again, we can alert with success. So we're going to say alert success like that. And then we can do the same thing with our catch. So let's just copy this. Really, I could have copied all that. Okay, so that's it for selling. Next, we need to write buy, and then that will actually conclude our function. So I'm going to say async function buy. I'm going to say await get access. I'm going to say const token amount is equal to document.get element by ID. This is going to be the tokens to buy, I believe, dot value from the input field. We're then going to say the const value is equal to await get price, which is getting the price of one individual token. And we're going to multiply that by the token amount, so we know how much we need to send to the contract to buy this many tokens. Then we're going to say await DEX contract dot buy. We're going to buy the token amount, and we are going to pass the value of value to this function. And then again, we can have our dot then and our dot catch. Okay, that should be it for all of our functions. We have buy, sell, grant access, get available tokens, get token balance, get price, and get access. Now, I just want to quickly check something here. I want to go and have a look at who deployed the token contract. So we can see that this address here, ending in AA3, is what, actually, no, sorry, that's not the one. This address here, ending in 266, is the address that deployed this token contract. So they should have access to all of the funds or all of the tokens in this contract. So I want to check that in my browser because we need to have that address before we can actually sell any tokens. Okay, so I've refreshed. I'm going to go to MetaMask here. And account 3 ends in 119. Okay. And if we look at our other account, let's go to this account here. This ends in 266, which would be the deployer of this contract. I think this is the accurate amount of ETH, but just to be sure, I'm going to go here and reset the account. So settings, advanced, reset account. Okay, let's refresh. And now let's look at my token balance. And okay, it's 100. So that's exactly what we wanted. We have 100 tokens. Now what I want to do is grant the DEX access to, let's say, 10 tokens. So I'm going to grant, MetaMask is going to pop up. Okay, let's confirm this transaction. Success. Nice. That is working. Now that we have that, let's sell the tokens to the contract, right? So actually allow it to do the transfer. Now we will confirm. Success. Very good. Let's check our token balance. If I run it a few times here, actually, let's just refresh and rerun. Now we have 90 tokens. Okay. Tokens available, 10. That's how many are in the contract. Token price is 100. Now let's go and change our account to an account that can buy these tokens. So let's go to account 3 and let's try to buy some tokens. So we want to buy 1 token. So first, let's update our balance to 0. Okay, let's buy a token. And we got an issue. It says buy tokens is not defined. Okay, that's probably because we misnamed the function. Let's go here and change this to say buy, not buy tokens. Okay, let's go back, refresh, and let's see, we have 0 tokens. Okay, let's try to buy 1. All right, brings up MetaMask. Let's confirm. And we got an issue. It says not too high, expected not to be 0, but got 3. Note the transaction cannot be queued. Okay, so this error happens when your accounts are out of sync. So again, what I'm going to do for this account is I'm going to go here and I am going to reset it. So I'm going to go here, advanced, reset account. This is just because if you're constantly turning on and off the dev server, it kind of messes up the accounts. Now let's just refresh again and let's try to buy 1. And hopefully this time it's going to work. Okay, so buy 1 token, confirm, success, my token balance. Now, if we give it a second and refresh, it should be equal to 1. I think it's going to take a second. And there we go. Okay, our token balance is now equal to 1. Tokens available is 9. Of course, the price has not changed. There you go. We have just written the front end that allows us now to use this DEX contract to buy tokens, sell tokens, etc. Now, of course, we could have implemented the controls to withdraw our funds and to withdraw the number of tokens. I'm going to leave that to you if you want to write that specific code. Again, at this point, you should now know how to do that because I've showed you how to do pretty much everything else. So it's just a matter of kind of replicating this and calling the correct function. With that said, I am going to wrap up the video here. I hope that you found this project helpful, and I look forward to seeing you in another Blockchain Expert video.